All right, we are on our way. We're near the bottom of our list. We're on to the derivative of uh, secant inverse of x. So we have the secant inverse of x equals y, and we're going through this process. We're taking the secants of both sides so that we can deal with something that we know. These cancel. We have x equals the secant of y. And now we can take the derivative, dvx, and on the left side, the derivative of x is just 1. The derivative of secant of y is listed here, but using a rule that I've mentioned several times, we think two secants and one tangent. We have secant of y, tangent of y. And of course, we need to multiply by the derivative of y. So we use implicit differentiation here. So we have 1 equals the secant of y times the tangent of y. I'm going to go ahead and divide both sides by this. So we have dy dx by itself. We have dy dx equals 1 over secant. But yeah, let's go ahead and write this. 1 over secant of y, tangent of y. Or 1 over secant, I can make a note here, note 1 over secant of y is equal to cosine of y. Okay, so 1 over secant of y is cosine of y. 1 over tangent of y is cotangent of y. Okay, and just like in the other videos, we come to this equation, x is equal to the secant of y, and we bring that equation to this triangle and we say, we call some angle y, and we say that the secant of that angle is x. So secant is the inverse of cosine. So the hypotenuse over the adjacent side. And whatever we're starting with is our x value. So the hypotenuse is x, and the adjacent side is 1. All right. And that allows us to find the side w by doing the Pythagorean theorem. 1 squared plus w squared equals x squared, or 1 equals, oh, we don't want 1, we want w. We want w by itself. W squared equals 1. Oh my gosh, all the mistakes on secants. W squared equals x squared minus 1, or w is equal to the square root of x squared minus 1. Square root x squared minus 1. And we just need to fill in what we have here. So cosine of y, the cosine of y is the adjacent side over the hypotenuse, 1 over x, and the cotangent of y is the adjacent side over the opposite side. So 1 over the square root of x squared minus 1. And you'll notice this is, not only was the derivative of sine inverse very similar to cosine inverse, cosecant and secant are extremely similar. They're just, one is positive, one is negative. X square root x squared minus 1. And I was mentioning that these are similar. The derivative of the inverse trig functions we have the same rule. If something starts with c, cosine inverse, cosecant inverse, the derivative will be negative. So our last derivative will be cotangent. We expect that derivative to also be negative. Okay, I'll see you then.